Hello everyone. So let's continue our series of lectures. So this is actually part 4. So or this is actually the fourth video. Of course, the earlier videos I covered basics of AC, and in the series of videos, this is fourth video. And I intend to make multiple videos, maybe up to about more than 50 videos on the topic of power system analysis, and this is about the fourth video on it. So let's get started. And this is AC networks. So we have a question on the screen. So let's try to solve this question and then we'll take it from there. So first we have find the current in the 5 ohm resistance in the following circuit. So you look at the circuit here. We have a 5 ohms resistance here, and I am supposed to find out how much is the current in this circuit. So there are different methods. So I can use superposition theorem, or I can use Thevenin's theorem, or I can use mesh analysis. Or although mesh analysis is a more famous term for it, I would like to call it matrix representation method. Whatever it is, like when it comes to solving the problem, we'll discuss that. So first, I'll take up the superposition theorem and find the current in the 5 ohms resistance. So let's do this. You might have heard about superposition theorem while you're solving DC circuits. So the same also applies for AC circuits also. So what you have now here is an AC circuit, and the objective now is to find the current in the 5 ohm resistance. So using the superposition theorem. So let me begin the answer. So using superposition theorem. So in superposition theorem, we take one voltage source or one source at a time and then calculate the current, and then we'll finally add all the currents. So let's take the first voltage source. At that time, the other voltage source will be short circuited, and if there are any current sources, they will be open circuited. So I have two sources in the circuit. So I'll take the first source and then short circuit this, and my objective is to find the current in this. So I redraw. So taking the first voltage source. So I have a voltage source like this, and it is 40 at 0 degrees. So this is the voltage. So as you know, this is RMS voltage, this is the phase 0 degrees. And then I have a 3 ohms resistance, and then I have a minus 4 ohms resistance. So by the way, this is not resistance, this is inductance. So that's why I put J3 and minus J4 as the capacitance. And then I have two parallel paths. So one parallel path is 3 ohms resistance, and this is short circuited, and then other parallel path I have 5 plus J6. So this total is one impedance I am writing. So now my objective is to find the current. Let's call this current as IA. So this IA is the current because of the first voltage source. So how do you find the current? So we have to find the total impedance and then find the total current, and then using the current division principle I will find the current in this one. So let me write it down. So what is the total impedance? Total impedance as seen by the 40 volts voltage source. If I look in this direction, what is the total impedance I see? So the total impedance is J3 plus parallel combination of 3 and then 5 plus J6 minus J4. So this is series with this parallel combination. Again, it is series. So what is parallel combination of 3 plus J6? So it's nothing but 3 into 5 plus J6 by 3 plus 5 plus J6. So J3 plus 3 into 5 plus J6. So just like your DC circuits. So 3 plus 5 plus J6 and then minus J4. This will give me the total impedance. Now once I have the total, I think let's calculate that. So I'm going to my MATLAB interface to calculate this. So I just switch over to MATLAB interface. So here, so I'm just defining the expression for my total impedance. So here, this is what I'm going to type here. In fact, I don't need to use editor, I'll just use a command window itself. So I have 3i plus 3 into 5 plus 6i divided by 3 plus 5 plus 6i. So this is the parallel combination, and then finally minus 4i. So remember, in mathematics we use I as an imaginary number, and then whereas in electrical engineering we use J, so it is both are equal. So I am getting the total impedance 2.28 minus J.46. So let me write it down. So after solving it, I had 2.28 minus J 0.46. So this is my total impedance. So ZT. Now once I have total impedance, it's very easy to calculate the total current. So what's my I total? This is nothing but V total by Z total. So that is nothing but 40 angle 0 degrees divided by ZT. So that will give me the total current. So let me do that. So this is basically 40 itself, 40 plus J0. So let's go to the calculator, and then I have the solution. So let's store this as ZT. So 40 divided by ZT. So this is my IT. So 16.85 plus 3.4 J. So I get 16.85 plus J 3.4 something, yeah. So this is my current that is flowing from the main source. So the current IT comes here. Now what is the current in IA? So this is, I can simply use the current division principle. So total current multiplied by the resistance or impedance of the opposite branch divided by the total impedance. So I get IA is I total into 3 divided by 3 plus 5 plus J6. This is simple current division principle. Again, as you normally do it in DC circuits, we do it in AC circuits. Only thing is we are operating with complex numbers. That is the only difference. So let's, this is again fairly simple to do it in the calculator. So IA is equal to IT multiplied by, this is a simple current division, 3 divided by 3 plus 5 plus 6i. So this is the calculation. So I am getting the IT current that is flowing in the 5 ohms resistance, that is 4.658 minus 2.218. So this is, of course, there is J here. So this is the current due to source 1. Now consider second source. So when I consider the second source, so my circuit will become like this. So let me refer. So I have J3 minus J4 and 3 here. So that part I will draw it. This is short circuited. This is 3 ohms. This is J3 ohms. This is J minus 4 ohms. Then I have the voltage source here, and then I have the load resistance here, that is 5 ohms. Of course here I think something is there. What is that? J6 and 30 45. Okay, so this is J6 and this is 30 angle 45 degrees. Now this is the second source. Again, what is the current in the 5 ohms resistance I want to find out. So the same procedure, I just calculate the total impedance and then find out the total current, and the total current itself will be the current in this. But one thing you should notice, let's denote it as IB. So the current direction will be different because the voltage source has a plus side here and minus side here. Although it's a AC voltage, the phase is positive peak will come here. So the current will come like this and then go like this. So the expected direction of current is IB is like this. So the IA was flowing down and then IB is flowing the opposite direction. So IA minus IB would be my resultant current. So we'll do that when we are adding both the currents. So let's find the total impedance. What is the total impedance? Total impedance is, first I have the parallel combination. So these two are in series. So J3 minus J4 are in series. This one is in parallel combination with 3 ohms resistance. And this entire thing is in series combination with J6 and 5 ohms resistance. So this is my total impedance. So I can just simplify it. This is minus J parallel with 3 plus like this. This I can further simplify. That is nothing but I just multiply these two. So minus 3J and then divide and then add these two. So 3 minus J. This is the parallel impedance, equivalent parallel impedance plus J6 plus 5. So this is my total impedance. So let me calculate this now. So let's call it ZT2 to avoid renaming the variables. So ZT2 is minus 3I divided by 3 minus I. So this is the parallel combination. Then I have plus 6I and then finally I have plus 5. So this is my total impedance. Now that is 5.3, 5.1. So this is 5.3 plus J, sorry 5.3 plus J 5.1. So this is my total impedance in the as seen by the second source. So I just look at like this. So I see this is the impedance. Therefore, what is IT2? IT2 is the total current. It's nothing but IB because that's what we are interested here. So this is nothing but total voltage, that is 30 45 degrees divided by ZT2. So let's do that here. So 30 at the angle of 45 degrees. So how do we represent that? So V2 is 30 and then EXP angle is 45 degrees. So because it is degrees, I convert into radians by dividing by 180 and multiplying by pi. Of course, this is I theta. So that is, I have to multiply with I also here. So this is the conversion of polar representation and then I get what is V2. So V2 is 21.21 plus J 21.21. And then now I get IB, which is V2 divided by ZT2. So I'm getting 4.0779 and then this one. So this is the current. So let me write it down here. 4.077 or 078 plus J 0.078. So this is my current because of the second source. So therefore the final current, the resultant final current in 5 ohms resistance, because there are only two sources, I do it with two sources. Otherwise I have to do multiple sources, 3 or 4 sources. I have to find individual current by each source and then add them. As I mentioned, the angle or the direction is IB is going upwards here, whereas in this the IA I considered downwards. So therefore I have to just take the resultant current as IA minus IB. So the total current will be IA minus IB. So this is I already have them stored in the variables here. So I'll just use IA minus IB. I should use capital IB. Okay, so this is the current 0.058 minus 2.296. 0.058 minus J 2.296. So this is the answer. Now I can express this in polar form. So how do we express this in polar form? So let me mark this as I5, that is current in the 5 ohm resistance. So absolute value of I5 and then angle of I5. Of course, this angle will come in radians. So I want to multiply by 180 and divide by pi to convert it into angles or degrees. So minus 75.82 degrees. So this is the final solution. 2.3687 2.3687 at an angle of minus 75.824 degrees. So finally, this is the solution that we got using superposition theorem. Superposition theorem. So this is the solution. Now, if I use a different method, will I get the same solution or a different solution? So that is what we like to find out. So let's continue that. I would like to use Thevenin's theorem, but then we'll do it in a next video. Thank you.